Today we're going to be making a flat light box. I bought this A3 panel off eBay a lot of years ago when I didn't think I was going to be able to find one again. I tried to use an EL sheet, which in my last house move I appear to have lost, which was A2 in size, which was in order to do the flats. I'm going to try with this. You can get these on eBay and places like that for like 20-30 bucks. They light up with different levels of brightness. Ideally I would want an A2 size so I could use it with the LX200 10-inch. 10 inches across this way is actually going to not quite work. It's not big enough. But it's good enough for the wide field for now. If this goes well, I'll attempt to maybe make a bigger one. So what we are planning on doing is using the fact that we can adjust the brightness levels of these to get an appropriate amount of brightness to do flat fields right in the middle of the count on the histogram when we're looking for a nice even flat to get rid of the dust bunnies and that kind of thing. So we can use pulse width modulation to adjust the brightness of the LEDs that are in this panel. The bits and pieces that we're going to need are a little project box to put our end result in. We're going to use an Arduino Uno. This is a clone. I just got it from JayCar, and a MOS module which is going to provide the pulse width modulation. So this is a pretty straightforward setup, and the reason why we're going to be using this gear rather than just simply a pot that could adjust the voltage, well, not the voltage for the doing PWM, would be that what we're going to use is hook this up via USB to the computer. So programs like SGP and APT are aware of these kinds of modules and can control the brightness programmatically. So they can take an exposure, work out what the ADU count is, and then either increase or decrease the brightness programmatically for a set exposure to hit the sweet spot. So it will iterate through those itself rather than having to take an exposure, adjust the brightness, take an exposure, adjust the brightness, and so forth. So this will automate that process. Now, the other part of doing this is that ideally I'd be setting this up, mounting it to the wall of the observatory, and setting up as part of a script that kicks off doing the flats, even with the observatory closed. So ideally I would literally mount it to the wall in a certain position. I'd slew the scope to it, set up the script to get the software running, to do all of the exposures, to get the flat images, and then I can start off on the imaging session. So that's the general gist of it. I'll provide a link to where the schematics are for this, and it's really pretty straightforward. Now, as I said, this is very much overkill for just adjusting the brightness of this panel, but what it allows us to do is use the software to programmatically control the brightness and iterate, so that would just effectively make it way quicker to get to that point, and literally to completely automate the process rather than having to sit there and fiddle with it. The power supply that comes with this panel is a 12 volt, 500 milliamp supply. No, it's actually 1000 milliamp, 1 amp supply. So all we need to do is effectively bypass the controller that's on here and just get 12 volts to the panel, and we can use the PWM controller to adjust the brightness. So what I've done is simply cut off the end of the plug and just get my 12 volts coming off here. And what I've done is get into this. Now I've already done this, so I'm just going to sort of pull apart everything the way I did last night. I just went through the back edge of here with an X-Acto knife just on the corner. The power is over here on the side, and pulled up one layer. And you can just see there's a little bit of just glue around the edge. And then in here was the circuit board and power connector that was just sort of in there. So I also have this other backing panel here, this white backing panel, and then you've got just the sort of translucent panel here. So I was able to then look at this, these two wires here that go to the panel, which was connected to the switch here, simply like that. And I've worked out which one was negative and positive. Just mark those with a Sharpie, just so, because they're sort of crossed over. So all I'm going to do is strip back these wires and connect up some extra wire to these to run them out to the PWM controller and work that. So before, this used to run at 3 brightness levels, which were all fairly bright, which wouldn't have been necessarily appropriate for this. So what I'll do is just strip back these wires, hook up some wire onto them so that we can just show you how it works. Now, just to show you what happens with the panel at full 12 volts, I'll just strip back those little wires there. I've got my little bench supply. Hook up the ground there and prepare for excessive brightness. Alright, so that's the 12 volt panel lighting up there. It's probably throwing everything off on the lighting on the camera, but that's the full 12 volts. So what we're trying to do is get this down to a much lower level. My power supply there is saying it's drawing just a smidge over an amp. So I'm just lowering the brightness. That's 8.6 volts. It's probably adjusting. The camera's adjusting 7.7. It's still producing light at that level, and at about 6 volts it's producing absolutely nothing. 7.6 volts there. It's actually lit up. You probably can't tell because of the compensation that's happening on the camera, but let's just jack that up to 12 volts. Yeah, that's 12 volts. So quite a lot brighter. That's what we're going to get as a result. So that's what we're looking to automate. So I'll get on with a bit of soldering. It's got our 12 volt connection sorted. Just going to run that through that gap where the old power used to be. Utilise that little bit of sponge there to just keep things flat. I might come up with something a little bit to make some strain relief there, but hopefully that has done the job from the standpoint of getting us some wiring out there. So cool, it's our 12 volts. This is the wiring setup that we're going to use. We are going to power from our power supply. Going to run 12 volts to V in and the ground to ground on there. We're going to run to the panel the bright panel. That's going to be plus 12 and that's going to be ground. And what we're going to run from the signal is going to go to pin 3 from the Uno. We're going to then run 5 volts and ground on the Uno there. So what that looks like in real life is we're going to run signal from here, right, to pin 3 on there, and then we're going to run 5 volt and ground over to here. Power in is going to come to there, and it's going to run out to the panel. Okay, so let me just get that wired up. Okay, so we will make yellow and green. Yellow can be ground. Green will be 5 volts. And blue can be our signal. So yellow is going to be ground. Green is going to be 5 volts. And blue is going to be our signal. Okay, so when I power this up, it's at the moment won't do anything because I need to load the sketch to run the program here. So I need to go and do that first and load it up. So I have downloaded the sketch. I'll provide a link to that. It's only been worked on just recently, last month. The only change I've made to the code is making it point to pin 3 instead of pin 13, because pin 3 allows a higher refresh rate. So I can upload the sketch, and you can see that, you know, it is now done and ready. So I can go to the monitor so I can send commands to it to see what it will do. So over here, these are the commands that you can send to it. So this is going to request the status, so just paste that, and it's returned, so let's have a look, returning the state, which is going to return S, II, which is going to tell it what the product is, which doesn't really matter because this is not a real device. It's just emulated. Then QRS. So Q is motor stopped, so that's that character. Then the second one is if the light is on or off, so it says it's off. And then the last character is S is if the cover is not opened or closed, because it doesn't know. So this is what the product that's emulating. So what we can do is tell it how to set the brightness and so forth. So what I'm going to do is physically plug in, so everything is right here. I'm going to physically plug in the juice and request it to turn on the light, which is with the L command. So if we're lucky, this should turn on. Great, but we're not getting, oh, maybe the brightness is not set. So let's have a look and set the brightness to, so just B 255 full brightness. Let's have a look. Whoa, there we go. So that apparently is full brightness. So if we send the command to go brightness 128, which is 50%. Yeah. Hopefully you can see the difference in what was happening there. We'll go brightness 10. That is actually still on. I know it's pretty difficult for you to see, but I can tell from the side that there's actually some light coming there. So brightness 255 again. Great. And so if I send the request to see what its status is, so, or confirm what the brightness is, so if I get request J 000, it should return me 255. So it has, it's told me that the brightness is currently set at 255. So that is working. So we're just going to mount our box like this. And just something like that. Doesn't really make too much difference, although that's probably nice there. So what we want to do, get the box cover on where I want the wires to come out. Just use a nibbler to cut out Okay, so we'll just reattach this with some Velcro maybe, I think is a good idea. And that way it's just ready to go for putting in the observatory.